device, which is like 2 centimeters to 3 meters, and then it verbally notifies the user of this distance in the form of a voice message using the text-to-speech, which you can see right here. And then we also added informative features such as temperature. A little temperature sensor is going to tell the ambient temperature of the room. In making this device, we had 3 thoughts. We thought about replacing the traditional blind cane with this device, which is a handheld device and which can be used multi-directionally. You know, with this your regular cane, they can't point it anywhere because they can hit people. But with this one, like you can see, you can point it in any direction. We also try to maximize on their hearing sense by allowing them to listen to the distance. And one more thing, we were trying to provide reliability for them, allowing them to complete everyday tasks independently without the need for other human help. And as I said earlier, we also have a temperature feature. I'll hand over to Mustafa.
So far, we have used the following components in our device. We have an ultrasonic sensor, a temperature sensor, text-speech device, a keypad, a headphone, Arduino board, and 9-volt battery. So the way it works, ultrasonic sensor will send a signal and comes back, and it goes to the Arduino board, which does the calculation, and it goes to the text-to-speech device, and from the text-to-speech device to the headphones, and which notify the user of the distance. We also have a typical dial keypad, which Michael is going to go over it. However, this keypad can activate different features, such as temperature. We can tell the temperature if you press number 1 in the keypad. And also it can activate, as I said, activate different features. I'm not going to go over it, so that's Michael. And yeah, that's it.
So here we have the components of the internal design of our project. We have the ultrasonic sensor, the temperature sensor, the Arduino board, the keypad, and the headphones, which was all necessary to make our project. And here we have the overhead view, the sides, the frontal, and the back view. So for our project, we wanted to print out our box using a 3D printer, but along the way we encountered some technical difficulties. So we opted with just going using a cardboard box.
Here we have our device, and behind me is where we have the coding. This is the header. As you scroll down, this is where everything takes place. From this point, we have the temperature feature, which if you press keypad number 1, it will tell the user the surrounding temperature. Say if you press 1 right now, it will say 75 degrees in here because it's hot as hell in here. If you scroll down further, sorry. Well, volume 2 controls going volume up. Volume keypad 8 controls the volume down. Keypad 3 controls the different voices we have, which is 3 male and 1 female. Keypad 4 and 7 controls the rates, how fast the speech is when the robotic voice inside the system speaks to the individual. And keypad 5 we have for different languages, which we have at the moment is English and Spanish. Keypad 6, 9, pound, and star doesn't function anything at the moment, but in the future we'll be using keypad 0 as a time feature for the individual when they want to use it, which we will be implementing in the future, like I said. In a few moments we'll demonstrate the device and I'll pass it on to the team.
Yeah, right now, yeah.
Okay.
Hello, Philadelphia. I see Val and Suga. Hi. You can hear us, right?
We can, loud and clear.
Okay, great.
You can go there.
So, do you want to go inside? Do you put the battery?
It's working. Just a few seconds, please.
I think the mini is supposed to be inside by the pattern.
Yeah.
It's in the back. We have it. We have it.
And you edit it. Sure.
Okay.
How come I'm not hearing?
No. That's the only thing that you're saying. Did this stuff. You see it,
Object 98.59 centimeters or 38.45 inches away.
so that was the distance.
The temperature is 17.09 degrees Celsius or 62.76 degrees Fahrenheit.
That's the temperature.
You want to step in front of it to show
Yes,
the
let him finish first because it takes time.
Object 87.24 centimeters or 34.02 inches away. Object S object 34.14 centimeters or 13.32 inches away.
Yeah. I'll change the rate of speech.
Object 99.21 centimeters or 38.69 inches away.
Change it and put it as the one.
Object 97.59 centimeters or 38.06 inches away.
It's going very fast now.
Object 96.61 centimeters or 37.68 inches away.
And then I'll change the language.
It's not perfect Spanish, right?
Yes.
The temperature is 15.14 degrees Celsius or 59.25 degrees Fahrenheit.
Is it
The
8?
temperature is 14.65 degrees Celsius or 58.37 degrees Fahrenheit.
Language 5?
Yeah.
Ok, 9.8,6 centímetros sobre 3.8,4 6 inches away.
Does it sound like Spanish?
Cuatro and ocho.
So this is
Ok, 8,
basically
7,2.
so this is basically our device. So right now we have plans for the future to add the time.
Right.
So they will need the visual impaired will need to ask somebody what the time is. This is all about making it everything independent for the visual impaired.
And that's why we have unassigned keys on the keypad, so in the future we can just add a feature to them.
Yes. So any questions?
What happened to your box?
The box? Oh, I think Lynette spoke about it. We tried making the box on the 3D printer, but we had some technical difficulties, so we opted to go for the cardboard for now.
Any other questions?
Do you mind passing the device around?
Yeah, sure, we did.
Should I submit it?
Yeah.
And there's no. Yeah, so this is just. It looks
I do have a question.
Question from Suga.
Walki?
Yeah.
Hi guys, first of all, great project. What is the cost of the project? How much did it cost you to build this?
Okay, so the text is, well, I can't tell you the price of the components that we used. Each one. The ultrasonic sensor was about
$4.
no, $6. The text-to-speech device was the most expensive. It's about $75. Arduino board was about $9.
Nine.
From it was Micro Center.
Yeah.
The temperature sensor was about
16.
15,
No,
16
Yeah.
dollars, and just some wires.
So about 120?
Yes.
About 100, yeah.
120 for the parts, great. But then, how much time did you guys spend, for your labor? So the total cost to build something like this.
Labor.
Honestly speaking, this is a student project. You know what I mean? This is a school project. We didn't really do the math so much on it, like how much it's going to cost, like if we were to, because this is only a concept kind of thing.
Yeah.
It's a prototype for now.
Yes.
It's not professionally made.
So I'm just trying to ask, how many hours did you guys spend from that point?
Okay. How many? Well, we had in the first session we tested. I mean, it's a period of 8 months total.
Yes.
It's the whole senior project, which is 4 sessions.
Maybe an hour a week on the project?
Yes.
Hour or two.
Hour or two.
Especially in the beginning, we were spending more time.
Yeah, I don't know. Just in a real world scenario, and if the similar product is available in the market, you know how much you're going to pay for it, and how much did you spend to to develop and create. So just to give you an idea of a free future, things what you may want to do with this.
If we were to have the time for it, like, because we had other classes with it as well. If we would have the time, like, just like 2 months, 3 months for us.
Yeah.
Because we were done with 90% of the project in the first.
I think they're asking, like, in general to manufacture. I think now that the idea and the know-how is there, I think it can be built in a couple of days. Is that what you're asking?
Yeah, exactly.
So now, if you have the code in parts, it'll take maybe a day to put it all together. It's that simple. But it took them 8 months because they had to go ahead with the planning and research and all that. Yes.
I really like the idea of the multi-language. From looking at their sensors, it came to my mind, especially when you have these cameras in your vehicle with the reverse, when you back it up, it can tell you. Then if you are a person who speaks Spanish or some other language, you can push a button and then it can say it. So there are lots more other opportunities you may want to do. From
We
this. Great.
did intensive research as well, and this is to be the first device that can actually talk and notify the user with the distance. Other devices just do the sound.
Yes, or vibrations or stuff like that.
It would actually, this device would actually tell you the distance in like language.
Can you use this sensor in the water, in the ocean?
No,
it's not waterproof.
Yeah.
Okay, second question. Did you make time estimation for your project?
Yeah, we had a project plan. We had
If you could say how long you did it, why you were able to advance the population?
Can you repeat the question one more time, please?
If you need time estimation for your project,
Time estimation for our project.
yes, you could tell person how long you did it.
The problem with that is in the first session, we finished 90% of our project, but because of the courses, we had to take our time and go through the courses, which is 8 months. But if it wasn't for that, within a month or two, we could be finished with it. But because of the sessions, we had to take our time and do everything.
Because it's a progress, it's a process that you have to go through.
Yes.
Congratulations on the concept and your presentation. You did a good job.
Thank you, sir.
Did you only get a reading if you press one of those buttons, or
no?
It's always running.
For the
It's
distance,
always running.
yes. For the distance, it's always on. But if
how
you
frequently
want temperature,
does it give you a reading?
It gives you a reading every time it scans the object within the range. So if there's an object in the range, that's the only time it's gonna give you a reading.
Okay, so if someone crosses
Yes.
that path, it'll give you a reading.
Yes.
Yeah. Very
And then for the temperature, you press a button, stuff like temperature and change
Yeah,
it.
that changes.
Yeah.
All right. Good.
I have a question. It's definitely a great idea. Do you know what's your range when it's scanning? How?
He talked about it.
Yeah, our range is the range of this sensor is 2 meters, 2 centimeters to 3 meters. But at this moment in the code, we have it up to from 2 centimeters to 100 centimeters. Because
Because I'm looking at how wide is the skin? Something.
it's a cone shape, but we're not.
Typical ultrasonic sensor, which is about 45 degrees.
Yeah.
45 degrees.
And the other thing is, I thought maybe one of the features you could add also would be the vibration, because there could be a location where you don't want sound. Like so for some odd reason, you're walking into the room. So maybe the different levels of vibration. We could give them a sense how close something is.
Yeah.
Because not all the time maybe sound is allowed, and so they may want to be more silent and still be able to use it also.
Yeah.
So a double feature kind of thing.
Yeah, thank you.
Does that have Bluetooth for the?
Well, to minimize any mistakes, we decided to go with the wires.
Yes,
instead
and
of
then
the
we had a
wireless.
$200 budget too. So.
Okay.
They have headphones. You can use headphones.
Okay.
Regular headphones.
We just connected the speakers here so
Yeah,
everybody
so-
can hear.
I don't know if you guys saw, but on this text speech device, there's
I
a
did
headphone
notice
jack.
it, yeah.
Yeah.
Good.
All right, great
Good
job,
job,
guys.
Good job.